Thanks for joining and finding the room. It's the last one, so I don't plan it to make very long. I have only a few slides. So my name is Renato. I'm originally from Mexico City, but I work and live in Zurich, literally. And today I'm going to present you some slides about some experiences we have when we are making automation and a very simple process that is patch vulnerabilities. It's very simple. We all do it every day, maybe. But I found it interesting to show it in this context of this DevOpsCon. Because first of all, I never seen a presentation like this before. And also it was not so easy to make the patches for like in any other environment I work. My background is in robotics. It's a long story to how I finished in financial services. I guess mostly the pandemic will explain itself. But I was dealing before a lot of technical things and a lot of DevOps, a lot of backend, which is completely different of how we do it now in a regulated environment. This is the content of today. So I try to find the fanciest subtitles for each slide, but I don't know if I managed to do it. I'm basically going to show you what is the problem first in a simple overview, and then it's important for me to share with you how is the environment. In the beginning, some of us we were sharing our backgrounds. So for the ones that are coming from regulated financial services, maybe you see some similarities. And then we will end up with a very simple pipeline. Like it's really not rocket science, but in this kind of environments, it's very difficult to achieve it due to the dependencies and the internal mesh that this company has of relationships, people, talking, hierarchies, etc. So we start with a very simple overview of how our system looks. So we have people that take care of we have people that take care of the infrastructure, the one that we call the platform. I forgot to mention something important. I'm part of the financial risk management department. So inside Zurich, Versicherung, there is a lot of units, a lot of departments. We have our own IT department, which is self-regulated, which is regulating every one of the other departments. As a risk management, what we do is assess risks, everything that is related to risks. I normally work with a lot of mathematicians, actuaries, a lot of actuaries. The people that create some kind of models, mathematical models that resemble some understandings of how to translate some situations that happen in the world into numbers. This word is a keyword. I will repeat it 100 times, numbers. This is what we live for. Numbers that mean something for somebody, more specifically. As I was saying, we don't have a different, I guess this is very generic. We have a few services. We have a platform team. That's why I mentioned where I'm coming from. So we are the only unit in the corporate center that has our own platform team. So that's an achievement that we like to sell because we are kind of independent in the way we move the technology ourselves based on our needs. On top of our platform, we have around 30 developers working with services, different kind of services. And then we have the users. The system I'm going to talk about patching vulnerabilities is It's a homebrew system. It's an ad hoc system that we use to make calculations that at some point is like, you can imagine it like a massive, massive graph, which is node is like a process that somebody made, somebody is responsible, somebody made, somebody is the consumer, somebody is the producer. So it's a measure of not only the processes, but it's a measure of relationships, internal relationships, units and people. It's thousands of nodes that generates at the end few numbers. That these numbers are really important for us because they describe the health of the company worldwide. As you can imagine, Zurich Versicherung is everywhere. It's in 5 continents, a lot of people involved, a lot of business units. And many of those guys consume information from this system, which has to be always on, it has to be always working. Among these kind of services like we have, and specifically this one, the system for risk management, we need to give maintenance to absolutely all the layers that I'm showing to you. So I put here some examples, like, I don't know, 7 years ago, we still have VMware and changed to Docker. So we need to change and adapt all our layers to use Docker, for example. We have constant changes in our IDEs. That is, we mostly, I will focus now mostly in R and C++ applications. So when we change the IDE, which is RStudio, then we need to update, give maintenance of some layers. But more specifically, the use case that I'm showing to you now is about vulnerability patching for applications. So our applications, they live in each of these nodes that I told you in this massive graph. They are Docker images. And each Docker images is accounted as a possible item for vulnerabilities. In this slide, I want to tell you more or less how is our problem. It's rather not technical. It's just why, this is one of the reasons why we are doing what we are doing so complicated. So as I said, this company is global, so it has people working everywhere. And I couldn't find a better way to describe what we are doing than this irresistible force paradox. I don't know if you have ever seen it, heard of it. That says something like, what happens when an immovable object faces an unstoppable force? So we have 2 corners of this problem. We have as I mentioned before, we have our global IT department in this big company that is regulating us, is telling us how we should follow and compliance, all these rules that we have for be, in this case, secure. And on the other hand, you can call it an immovable object or unstoppable force, is our regulators. The ones we were mentioning, our regulators mostly are FINMA and BaFin. Our regulators are very, very important. We serve for them. As a financial institution, we cannot just exist without being regulated. This is on the interest of all of us, me as a client, because I'm also a client of this company, but also as normal people. Financial institutions should follow certain rules. They cannot just do whatever they want. So they are basically our consumers of absolutely every number that we produce. And they analyze it and they discuss it and they have a lot of relationship with us. In the case of Germany, it's the BaFin. In the case of Switzerland, we have our own version of it, but we have also in Italy, we have in the UK, we have everyone. As I was mentioning, this is the context of a very specific use case that it looks very, very simple. That's why I choose it, because everybody has vulnerabilities in Docker images, everybody has updated, everybody has patched them. Most of the patches, we structure the patches in a way that are logical for us, in the way that we have read and write packages on the operating system level. I put some examples here. Or we just upgrade our operating system. We change our Linux flavor, for example. We changed a long time ago from Cent to Alma. We almost always use Red Hat flavors. But sometimes we have changes that are in the kernel. Sometimes there are changes that are in a glibc, or we are very optimized and we use Intel libraries to calculate faster our numbers or communicate faster through our threads, for example. So when there is change, a new version of a library, we cannot just install it. that's where this problem is originated. When we recompile our interpreter in R, or when we start to compile our applications in C++ with different flags, then we certainly will produce numerical differences. These numerical differences are important because we already told our regulators this is the state of the company based on these numbers that represent something for them. Assets, accountability, a lot of things that we calculate in a massive system that I told you that is like a graph. Imagine a massive graph of thousands of nodes that every node is a process. So there are a lot of people working in this graph. There are a lot of processes feeding each other. And then at the end, we produce certain numbers that mean something for somebody, mostly money, let's say, related to money. We cannot just change the numbers, right? This is the core context of this speech. We cannot just change and install the latest Intel version with the one API is called. We cannot just do that unless we are certain that the numbers match what we were saying before. That's why we need to start tracing what we are doing. So as you can imagine, we start doing everything manual. So clicks, a lot of clicks, a lot of typing, a lot of people involved. So the use case to patch vulnerabilities. At the same time, we are working with our normal BAU, right? So we are receiving stories, these 30x developers, 30-ish developers are working in developing stories. We have a structure that is kind of a developer, then some quantitative analysts, then the stakeholders. And the stakeholders could be modelers, could be risk owners, could be this kind of profile people. Some of them will be more IT savvy, some of them no, not at all. But they are really good in Excel, if you count this as a technology. They are amazing in Excel. I have learned things that I never imagined you can do in Excel. And Excel is our currency. We change Excel files all the time. So imagine that these irresistible forces, on one side, we have IT telling us you need to patch. You're insecure, you're creating holes in our system. On the other side, we have our regulator saying, you don't change any number unless I tell you. And the next year. And we are asked from our global IT to say, change numbers every month. So that's what is the challenge in this talk. At the same time, we have all these stakeholders asking us to make stories, right? So make a ticket, we need to change some things for the new regulation. Now the standard model 2 is blah, blah, the solvency 2 is blah, blah. Now the cat people, the catastrophe is changing stuff of how to calculate a risk for the war development and just inventing things we actually don't do it. But patching vulnerability that looks so simple, it becomes some kind of when do I do it? These guys are changing all the time the code. These guys are changing all the time the data. When do I have time to do it? That's when we come with this dual run concept. So as I told you, as I explained before, we have this massive system that has a lot of nodes. We have produced a suite of tests that are very important for us. And this is our fundamental step for it. So we have some layers, not like the environment, it's the operating system. We work on Linux, we work on C++, we work on R on top of it. R is because it's kind of the meeting point between Excel and computers. So that's why we use a lot R. But there are some engines that are working on the R with C++. So the idea is that we produce suite of tests. First of all, unit test and component test. And then we are working on integration test of this massive system. So how a little change here affects the full graph of dependencies. So that's why we are very, very important in how every single change in a patch of these nodes has the effect on the numerical changes. A bit more tracing of this dual run. So we soon realized that patching has a cost, but it has a bigger cost if we don't do it. We literally thought not to do it because of this clash of requirements that we have. It's irrelevant to do it. The model just gets old, but then because of audits, because of certain aspects that happens when you work with models, of mathematical models, they have to be kept used. So we have to patch them. The fact that we don't patch them is a lot more, increase the cost of not doing it and the risk. And as I mentioned before, I mean the risk, financial risk management, so we care a lot about the risks. So it's a lot higher risk to not patch it than patching it. So we accept the challenge to do it. So we are telling to our group technology that this is the IT of the full company that we are going to patch every month on time. What we want is to reduce the weaknesses of whatever unauthorized access we are producing in our own system. So at this moment, we have an old system that is the one we start to work every month. But every month we create a new environment, not system, sorry, an old environment and a new environment that we update every month. Every month we are moving like this. When we report a number in the old environment, we sign it with blood, right? So we say, this is our guy, this is our numbers, this is what we report to the shareholders, to the board, to everyone. So then we should not change it. So we developed this technique of dual run that has some kind of tolerance in between, depending on the type of number. The numbers are really, really important, what they mean. So some numbers are more important than others. Some others we should not change 0.01%. So we go to the numerical precision of the machine to see how much it has changed and how much it propagates the error along this graph. So at some point, we have two environments with two different numbers in the worst case. This is what we don't want. So we want to mitigate the transitions as much as possible. And the only way to mitigate it is being agile, releasing, a lot of releasing. The more we release, is the easiest for us to mitigate that risk. So what happens in the worst case? I think that's what maybe is interesting. So it's not interesting when nothing changed. So I already told you that we logically split the patches in something that we know it will not have changed the numbers, which are mostly the read and write operations, packages. But what happens when we are changing the numbers? We know that the numbers will change. So these numbers depend on a lot of people, and a lot of people depend on these numbers. It's a very cumbersome description, sorry. But that's, I guess, the definition of corporate world. We need to identify, we need to work with a lot of people. We need to work with people that are owners of this code. We need to work with people that actually know how the maths behind this code work, and the people that actually made the code of these numbers, that produce these numbers. So we have kind of three different groups. So we work with them, and then we produce some kind of root cause of why these numbers are changing. Because the theory says, and we have many times confirmed that the theory is actually true, maths are perfect. This is the only thing that is saving us all the time. The mathematics around the models keep saving us, keep making the numerical values really, really insignificant. Because at the end, a number is a representation of some kind of abstraction that people did to represent some natural catastrophe, or to represent some politics, or to represent economy. Some kind of human concept is represented with a number. And mathematically, to me, it's beautiful how they change it and how they affect the maths behind the numbers to produce the same impact. What I'm trying to describe now is the stability of the numbers. So this is what we call stability. When the numbers are different, but it doesn't matter because it means the same. Mathematically, there are some, let's say, equations that have different solutions. So our systems are like that, numeric equation systems in this scope. So to look for a root cause of this, we don't look in the code only, we look in the maths of this code, and we look in the understanding of the maths of this code by the code owners. Once we have this triangle fixed, this is what we want to report. This is what we want to communicate to any kind of person that depends of this system. That's why I put here, we have correlated synergies. It's really impossible to do this activity without people around us telling us what it matters, and up to a certain point, it becomes monotonous. So if it becomes monotonous, we can automate it, right? These people, they always want to know something very, very specific. They always want to know something about their model. And we don't have the full coverage of the 1,000 nodes that I told you, but we have coverage of areas. So we have areas of, let's call it expertise of certain risks. In order to keep the coverage, we need to keep collaborating. It's like a never-ending story. And it was not fun in the beginning to come and say, you know what? On top of all the things you have to do, there's one more. We need to patch. We need to update. We need to make our system secure. And because of that, we need to have extra work. This was really hard to do. So we need to engage them. We need to have them on our side always. I promise you that this pipeline is very simple. This is the pipeline, and this is really, really simple. There's no rocket science behind this pipeline. Basically, we get the list of vulnerabilities that is given to us by some tool called Prisma. Then we create a patch. We are patching Docker layers, so we just create a layer extra. And then we test. With all these tests, we test absolutely every single node in this massive graph of 1,000 nodes, and we see the numerical differences. On your right side, you will see we producing an impressive amount of storage. So that's why we need to dispose legacy environments. But at the same time, we can decide at the end of the day if we still get the new environment, we keep using the old environment. There are some times when we need to keep using the old environment. Most of the calculations that we are doing is basically for using a statistical or stochastic methods, right? So in order to communicate the changes, we create we start creating some kind of Jupyter notebooks as reports, so to let the people be more active on the way the calculations are done. But that was not really it was counterproductive because they start to do changes on the code, and it was not what we want. We want just to see assess the numbers. So whenever we create a report, we basically want to communicate in the worst case that there is a change in the numbers, what we are going to do about it. And these guys need a lot of information. They need to know exactly how the flux of information is received in that particular part and is emitted to the next side of the graph. In the beginning, we started to create very simple reports, but then when somebody of us, we like to work with generative AI, and we start to plug it with some more interesting parts. So we can also use the documentation of the code. We can also, and if there is some interpretation of the models, we can also ask the tool to do it. So we don't even have a lot of code for the RAG. We are Microsoft children, so we are using Copilot and SharePoint for that. It's really easy there. It doesn't get very professional data. I don't know how to say it. So it has its limitations, but then it's starting like a POC and that's why the next slide is mostly related to the extended work on this part, because then we can explore maybe in Bedrock or something, different models exactly for doing that. What we need to communicate with the reports are to find the root cause. We need to communicate exactly which node has produced numerical difference, why, because we updated this library, because we updated, and what is the right way, mathematically speaking, to assess that difference. If we can one day automatically report what I just said, it will be amazing. Because it uses a lot of our time, of a lot of us. And that's where the cost is also impacting. As I mentioned, on top of everything we have to do, we have to keep updating not only the code, but this exercise will become updating also our models. our our context, the knowledge also as well. It has to be spread, so we need to update our knowledge. So this very simple pipeline become a very demanding exercise for some people. That especially if they don't like it, right? So as part of the further work, we want to communicate better. In the worst case, as I said, we keep the old environment, we keep the vulnerability, we isolate it until we change the next stage of the model. We also would like to see the propagation of the errors at some point in this system. So if we can see how the graph is mutating, then we have two graphs, right? So we have two realities of the world explained by this system. So we have the old one and the new one. And we try to maintain just one new one, because this is getting like the Marvel universe, no? So we just stick to one latest reality that is the one we produce every month. And then we are still, because we know so much about every of these models, we also provide a lot of support to these three actors, no? The code owners, the coders, and the one that interprets the models, let's say. And believe it or not, I'm done. Many thanks. I don't see questions in the chat. Do you have any question? Go on. Yes. Yes, with the security patches, the number change. Yeah, you're touching a very sensible part. So we cannot just change the code. Yes. Most of them, they don't touch the numbers. So let's say 90% of the patches, they don't produce any numerical changes. Yeah, so if we patch the curl, the XML, Git, zip, they don't produce numerical changes. It's just when there is another kind of patches that, especially the ones in the kernel or the ones in libc, they automatically produce changes. The same when there's a patch in the Intel libraries about threads or something, this will need to recompile. Yeah. Yes. And that's when we cannot just come and tell them, guess what, we changed the numbers. Yeah, so they still need to tell us to change things. And that's when it gets complicated. Yes, we're actually doing what you're saying. So the developers, what they do is they create the tests, they test the part, they have some component test, we call it, when we call a component a single unit of node. Whatever, we see it like a black box test. So each single unit node, it has inputs and produce outputs, and that's what they test. So they according to the specifications of what the changes of this node will require, then they will produce different numbers, and that's the idea, right? That's the story, producing a change in the code and as well in the data. When we test it all, we also have more coverage on those tests, and we are more accurate on how much is the precision of those tests. When the developer, the difference mostly is on the precision. So when the developer makes a test, they don't care if it's 1 decimal point of whatever, few thousands of dollars, they don't care. They produce what they've been asked to, that is change these numbers, these equations, this code, and that's what it matters, the story. As long as the story satisfies what it was required, that's the end of the story. But these tests are a bit more precise in a way that we care how much decimal points are changed, how much time it takes. There are certain aspects that tell us information about how that the other tests will not. And this is the suitcase that we provide. This is the integration test as well. So in the integration test, believe it or not, especially we have big monsters of 92 CPUs, let's say. So this kind of monster, when it takes 4 days to execute, but then it takes 4 days and a half, there's something wrong. And we just update the environment. We never change the code, we never change the data, we just update the environment. So half a day is a lot, especially if somebody's just there waiting for it. So, and it's not one person. I told you there's a pyramid of people, triangle of people that is not one person in each corner. There are a few people and the managers and whatever. So that also tells us information. Normally, this doesn't happen except in these big monsters that are multi-threaded, that are very difficult to debug as well. This is where it hurts. It always fails where it hurts. Is that okay? Yeah. So, yeah, thanks. I don't know if I understood the second question. Let's go with the first one. So you ask about the overview, right? About the cost of improvement. The cost. So yes, so it was not going to happen if we don't automate a lot of this. The cost, it was a few hours a week, times people and managers and people, platform engineers, developers, quants. So it was not going to work. At the moment, I didn't mention it. At the moment when we finish the pipeline, the pipeline is triggered by whoever triggers the change. So normally the platform engineers trigger the change. So the pipeline triggers and then produce all these reports. And we just have a very simple red-green table that tell us there's something wrong. And then if we keep digging, that's where we want to put most of our efforts now. We keep digging it and keep giving more detailed information. The idea will be that anybody can run it. So it takes only the time of that guy waiting for it. It takes around 3 hours to run everything, all these tests. Maybe less, but then the cost without doing that is a lot and it's unbearable. And it was very quickly a no. That's why we thought we don't do it. because it's too much. But then how do we tell our IT, global IT, we are not doing it? So it's not possible. So then that's where we developed this idea of having this very simple pipeline that anybody can run it and produce up to certain levels, very simple reports. So the guy that produced this patch, for example, will run the pipeline. The guy, if he sees everything in green, we just need to, somebody has to confirm that is, we always have to confirm. It's like we call it the second pair of eyes. We don't do self-validations of what we do. So we always need to have a second person that knows what is happening and says, yes, these builds are okay, the test runs are okay, patch it. And the guy, so then there's these two people that are patching, and then the guy just patches, and then the flow of this pipeline goes on. The second question. Yes, yes, I call it a hack, but it's not a hack. It's something that we call materiality framework. Materiality means if it's going to produce a change in the numbers that actually are money, very important money. So assets or whatever. So the hack is that we check those numbers only. So if we run several updates in different places, we just check certain parts of the graph. And I didn't mention it because it's not ready. So I will be lying to you. We have certain parts and we know already certain parts, but we haven't formalized it. So this hack is actually something very helpful because it's what the board, the senior management care a lot. So we don't really need to run a lot because also it takes days to run the full thing. And if we have two versions, no, nobody wants to do it. We have tools to do it, but it's still cumbersome. So we're developing with our business partner, let's call it this way, these guys that know the business logic, we're developing this framework that we know what it matters. That's why I put somewhere, there are numbers that matter to another. This materiality framework, we call it, is something that will be very helpful. And we will focus our reports on that. And everything that goes, the logic, if we keep using Gen AI or whatever, it will be based on those numbers, how they are produced, and we just go backwards. Because the other parts are important, but this should never change, hopefully. Does it answer your question? Yeah. Hi. Yes. So if I understood the question correctly, you were asking if a number was wrong or less to be correct, and then the patching will open the Pandora box, right? Or a can of worms, we call it. Well, this is regardless the patching, right? This is a change. We have them, but it's not only because of the vulnerability patching that we discovered them. So as we are heavily regulated, every single step to do that is also regulated and is traceable back. Wait. So in this particular example, there is a process to do it back, and we just use that process. So it's very uncomfortable. Somebody has to put the hands there to be spanked, yes. But the process is for that, for making even that human recognition, mistake, reconsideration. Also could be that somebody says, maybe we should take that direction. It's not only mistakes. Sometimes this happens a lot. And as I mentioned, the regulators are also people. So they work with us. We work together with them. They want, we want to be compliant with them. This is their success. They want us to be compliant. This is our success. So it's a very special synergy that we have with them. We are not friends. We shouldn't be, but this is it's intentional to have these processes. So if a vulnerability patching will discover one of them, we have a process that will go back, and then somebody has to do it very quick. Yes. Oof. Yeah, I will rather not answer you and answer you later that tell you something that I think we are using. So if you don't mind, at the end, I can take your information and come back to you because I have an idea, but they change it this year. So this year is the first time they tell to all of us, you need to patch, doesn't matter. So, and then they change themselves to be more reactive. So with this change, I don't know what they are using. So if you don't mind, at the end, I can take your data and then come back to you. Mhm. So your question is what happens when the CPU's architecture change or yes. So we recently have the change of hardware, but we normally use the same hardware. We have a pool of nodes talking about the Azure that we always use them. We have clusters of these nodes that we always use them and we share them and we manipulate with Kubernetes, right? So we have a process that use more, less, bigger memory. So we manipulate that way. When we change the architecture, we were expecting numbers. So we run the same thing. So the maintenance is run with the same pipeline. It's different. Yes. Yes. Yes, exactly. It's the same dual run. So we have the old one and the new one. The old one was with the previous architecture. We also have some uh, changes when we were, so we optimized somewhere in how some library called LAPACK for linear algebra, um, how they make the calculation. So Intel has a way to make it better and faster. Let's call it this way. It's a register, it's the AVX register, it's called. So when you change with the new technology, we did a lot of testing in order to change it. We just don't change it like that, but we change it and we verify that, especially for multi-threading, this change was very beneficial. So it was kind of an architecture change. The way the C++ applications were compiled. So it changed things in using different parts of the CPU, let's say, of the kernel. So then we first investigated, yes, the idea is that Intel says that when you change that thing, your threads will produce the same, more or less the same results. At that moment, and some applications, they still have it, they still have the old one. If you run different threads, they produce something else. So we always use the same amount of threads. So you cannot just increase the threads. You have 32, you stick with 32 the rest of your life. But with this change in this register of this how C++, the G++ compiles and it produces more or less stable results. So this was also kind of a change in Intel library that it produces different numbers. And then we do the same thing. So we've been doing not for vulnerability, but for other kind of changes. Also, when we change the R version, when we change dependencies, R is a mess. So it's like dependency hell, they call it. Literally, it's called like that. You can Google it, R dependency hell. And when there is like a change in the dependency, it spreads all over the place and it's horrible. So when we change version of R, then it also, we run the same pipeline. We produce different numbers and we have different precision, but we run everything from the same pipeline. So this pipeline has an impact not only in vulnerability patching, but also maintenance. So, and again, the same guy that changed the architecture run the pipeline in Jenkins, click, and then they produce some kind of very simple result that if everything is green, you can change it. And mhm. Um, I don't think we have this concept. I think at the moment we have these maintenance loops, we call it, sort of sprint. And we also have this requirement of every month. And we always try to live in the latest. The latest one is the thing we care. So if we have this concept of back generation, then it gets more complicated. So we keep an old one, a concept of old, and we keep the latest. But it is true that the concept of old could be 1 month or 5 years, or I don't know, their application. Yes. So, and the one in 5 years, it could be also that it's just this month. So next month it will be patched. So we don't patch things that we know we should patch, but nobody's using them. So they don't appear in the security that our colleague asked. They don't appear in the registers of the security vulnerabilities because nobody uses it. Only when it's used, it will appear. So then we patch. So we don't have this concept of generation. We just see what is this month happening and we go back 1 month. And then the next month we move back to this month and so on. Okay. Perfect. You're asking if we have some time requirements of how much? Yes. Yes, I didn't mention them because my slides are regulated. But, but we have, depending on the type of number, we have less or more regulation. And the regulation is about people, how they affect their work and how they affect the company health. So there are numbers that should never change. Or if they change, mathematically speaking, they should have an explanation. And then it's not the concept of less equal than or bigger than 3%, or it's not that concept. It's the math behind it. That is the concept. It's not numerical precision, the concept of tolerance, if you want to see it this way. It becomes to another level. But thanks God, maths are perfect. No. No, we have, as I answered before, we have these processes heavily regulated that these processes are studied by people not in our department, but somebody in another part of the company. And that's how we deal with changes in our company. Yes. No, because if it's going to be used the old, it's going to be used the old until we die. And then for that process, we create something that's called an exception. And it's really an exception, like a real exception. It should not happen. Because, and it gets flattened naturally, because most of the time there is a story about this thing in the next year somewhere. And the story will change things that will update to the latest automatically and will create a new number. But we never overlap things. If it's going to be the old, it's going to be the old. We play safe always. If it's always the new one, the latest one is the latest one, not the one of last month is this month. And the latest one, the next month will be the latest one of the next month. Is that clear? Yeah, thanks. Yes, so there are new patches every month. Thanks for the question. Does anybody has more? Thanks for the questions and for joining. Enjoy your evening.